We are learning about LAN technologies. Among several MAC protocols, especially we are focusing on this Ethernet technology. This one is probably last slide for Ethernet, and let's look at this one. This Ethernet is standardized by IEEE, and that is the standard number. As I mentioned already, this one is Ethernet, and number 4, dot 4 is token bus, and dot 5 means token link, and dot 6 metropolitan area network, and dot 11 A, B, G, N, and AC. Those are related to this Wi-Fi. Thus Ethernet, this one is most successful among many other MAC layer protocols. Here, this one is explained about IEEE 802.3 Ethernet standards. These Ethernet standards that is related to this layer 1, layer 2 among these 5 layers stack. And many different Ethernet standards are introduced around the 1970s, middle of 1970s, that first Ethernet standard that was introduced. After that, many Ethernet with different speeds, those technologies are being evolved and introduced, and we are using. Those are using common MAC protocol and frame format. And those are using different speeds. Initially, that was 2 megabps thin coaxial cable. After that, 10 megabps with thick coaxial cable and the twisted pair. And probably this one is the most popular in the world until now. And using the twisted pair, this 1 gigabps is possible. But fiber optics will be better to use this 1 gigabps speed. And from this gigabps speed, those are all based on fiber optic cable. And different physical layer media, this fiber optic cable and this cable here, twisted pair here, and this is coaxial cable, UTP. Mainly, those are being used. Here, above this one, usually gigabps speed, this fiber optic cable is being used. Okay, this one is standards, including that physical layer. This one is speed, and the base signal twisted pair, and the others simply based on fiber optic cable. Okay, let's move to the next. Next one is about virtual LANs. This subchapter is mainly about the contents of the virtual LANs. Before that, let's look at Ethernet switch first. This Ethernet switch, this device is link layer device. This one is taking an active role in Ethernet infrastructure, and this one is storing and forward Ethernet frames. This switch is examining incoming frames MAC address and selectively forward the frame to one or more outgoing links when frame is to be forwarded, one segment. And this one is using CSMA CD, carrier sense multiple access based on collision detection to access segment. And this one is transparent. This device and this device Ethernet will have many Ethernet interface here. This interface that's different from other PC interface and router interface. This one doesn't have any IP address or Ethernet MAC address. Purely transparent. Hosts are unaware of presence of switches. Simply transferring, we learn that from PC, that Ethernet frame, to the other device, router, or other switch, or other computer, that will be transparent, and that will simply transfer that frame. The hosts are unaware of presence of switches, and this was working in this way: plug and play and self-learning. In terms of that table here, this one is managing some table, and this one is self-learning table, and the switches do not need to be configured. PC or router, we need to configure. Even though that is configured automatically, we are trying to configure anyhow. We need to configure this one, and the configuration file, that is important, and the network manager should take care of that. Let's look at a little more about the switch. This one is multiple simultaneous transmissions. This one is providing that. For example, this one is switch, and this one is providing multiple simultaneous transmissions, the capability. Hosts have dedicated direct connection to switch, this host. And the switch buffer packets, here memory and the buffer here. Ethernet protocol used one each incoming link, but no collisions. As we learned, Ethernet, original Ethernet, that scheme was collision happening, and there's no collision. This one is isolated. This one is isolated, thus they are not colliding with each other. And this one can communicate in full duplex mode. Thus, at the same time, this one can receive and transmit. Each link is its own collision domain. Here. Like a separate room. Switching, think about this switching, A to A dash. Here, A to A dash. And B to B dash can transmit simultaneously without collisions. Here and this one. Without collision, they can transmit at the same time. And let's look at a little more about this switch, especially about switch porting table. How does switch know A dash reachable? This one is reachable via interface 4. This is interface number 1, 2, 3, 4, 5, 6. Reachable via interface B dash is reachable via interface 5. Answer is each switch has a switch table. Each entry will have this information: MAC address of host. Here, MAC address of this A, and interface to reach host. Interface number 1 here. Thus, MAC address of this A host and the interface number 1. That will be stored here in this switch table. And some information about the time to live, like that, timestamp. And looks like a routing table, but this one is switching table, a little bit different. How are entries created, maintained in switch table? This one is something like a routing protocol. This one is created in this way. That is different from routing protocol. This one is explaining about that self-learning. to configure that switching table automatically. That means plug and play mode, it is configured. Switch learns which hosts can be reached through which interface. And that information will be got when this host A is trying to send some Ethernet frame like this. Source is A and destination is A dash. That is the MAC address, Ethernet address. And this is the source. Thus when this frame is arriving here, then this one can extract, and that information will be stored here in this table. That is source A, MAC address, and 1. That means MAC address A is in this interface number 1. That will be stored like this, and some TTL value. Initially that was empty, and nothing is being sent, then this will be empty. But some frame is being sent, then this one will get that information like this, and that will be saved here. And this table will be configured automatically. When frame received, switch learns location of sender incoming LAN segment, and record sender location pair in switch table like this. A here and 1, interface number 1. This is the self-learning switch table. Okay, this one is showing the algorithm, how it is being configured in terms of software. When frame received at switch, first, record incoming link, MAC address of sending host, and index switch table using MAC destination address. If entry found for destination, that is the destination MAC address. If that is found, that entry found for destination, then it is checking again. If destination on segment from which frame arrived, if that is the destination and that is the source, and that frame is from that, then that will be dropped, because this is host and this is switch. The destination source is this one, and destination is also this one. Then no information, only the host information here. This host, this MAC address, and this interface, that will be stored there, and no other information. But in other case, host and send some frame, and the source is this one, and destination is here. Then that will be tried to be found here, and that is not the same one like this, then it is going out. Else for the frame on interface indicated by entry. Else flood. If that is not in that table, then no information. There's two other interface, all of that interface, those are sent. That is called flooding. That means pod 1 all interfaces except arriving interface. And let's go back using this one. And here, this one is coming frame, and no entry, no information here about the destination. Then that will be flooded like that. This one is explaining a little more about that. Self-learning and porting example. This one is source address and destination, as we used already in the previous slide. And here, destination was A dash, and frame destination A dash, location unknown, then that will be flooded. And this one will respond, destination A, location known, selectively send just one link. Later, any response from this one, then that will be stored here, and that will be saved in this switching table. And later, that is simply send from here to here, this one, through this switch. And in that case, instead of flooding, in that case, that is called the unicast, point to point. Okay, this one is explaining a little bit more about the switch. When those switches are used in this stack mode, hierarchically, switch and another switch, and another switch, and another switch that can be used. Also, this one is switch, this one switch, and that is possible. And still, those are using self-learning to configure that switching table. Also here, in the same way. Thus, you can hook up this Ethernet line here to any port of this Ethernet switch, and also you can hook up this Ethernet any port to any port in this switch, also any port in this switch from this also. In that way, so simple to configure. Comparing to the router configuration, it is very simple and straightforward. Question is sending from A to G here. How does S1 know, this one switch know, to port frame destined to G via S4 and S3? In the same way, the switching table will be configured automatically. And so is self-learning, works exactly the same as in previous single switch case. Another question, simple question to understand better. Suppose C here, send the frame to I responds to C. Also, this one is working in the same way. And those switch tables will be configured. C interface and also I interface that will be learned based on self-learning scheme. And the C, that MAC address here, and also MAC address, that those will be stored there. And I, that interface, I interface, then this link number, and the frame will be finally arriving there. Initially, no information, but this one is operating in plug-and-play mode. Thus, slowly, gradually, that will be learned, and that switching table will be completed later. Okay, let's think about this very simple institutional network. Any organization's network, like our university network or company network. To use the internet, this is internet external network, internet world. And this is a router. Usually this one is provided by the internet service provider. And this is switch. And we are using usually many different hierarchical switches, edge switch and more backbone switch. And here the speed may be different because this speed is in the edge. That speed usually 100 megabps. But inside we can use gigabps. And inside also we can 10 gigabps or 40 gigabps depending upon the requirement of that bandwidth. And this is the mail server and also proxy server that may be installed here. And the firewall, those can be installed here. This one is IP subnet, and these switches can be used here, here, here. Okay, this one is probably very simple network configuration, but usually much more complicated than this one. To understand basic concept, that will be enough, but more complicated architecture may be introduced in next slide later. Let's move to the next. Okay, this one is comparing switches versus routers. Here, both are store and port device. Routers, that is network layer devices. Thus, this one is examining network layer headers. Switches, this one is link layer devices, and this one is examining link layer headers. Also, both have porting tables. Router, this one is computing tables using routing algorithm and IP addresses. Switches, this one is learning porting table using plotting, learning MAC addresses. And this one is the layered stack. We are mainly considering this one about Ethernet, and this one is Ethernet frame here. If we are considering the upper layer here, then that datagram will be here, and that will be sent through this switch. Switch is simply two layer here, first layer and the second layer. And that is two layer device. And the router, this one, that is three layer stack device. And our host and our source host and destination host or server, that is implementing 5 layers stack. Okay, let's move to the next topic. This one is explaining about the virtual LANs. This V means virtual. That is opposite to the physical. Virtually, they are isolated LAN, and we will look at this motivation first. Consider, this is computer science department in here, computer science. In the university, consider here, CS user moves office to electrical engineering department, that building, but once connect to CS switch, single broadcast domain. If we are using single broadcast domain, broadcasting frames are going around. All layer 2 broadcast traffic, for example, ARP, DHCP, and unknown location of destination MAC address, those will be broadcasted, must across entire LAN. Then in terms of security and privacy, also efficiency issues, those are not so good. Thus, instead of this single collision domain, single broadcast domain, we need to divide into several, or here into 2 broadcast domain here. To do that, this virtual LAN technologies that will be used. What is virtual LAN? Virtual local area network. Switch is supporting VLAN capabilities. If that switch is plain or ordinary switch, and that is not supporting VLAN, then VLAN is not possible. Thus, if we want to use VLAN, then that switch should be VLAN capable. VLAN capabilities can be configured to define multiple virtual LANs over single physical LAN infrastructure. Okay, let's look at this one. There are 16 ports here. This one is port-based VLAN, and switch ports grouped so that single physical switch, this one is grouped as if it is single physical switch. And even though those are physically in the same switch, these different group and this seems to be different switch. Also, it seems to be different switch, even though those are integrated in single switch, and that can be virtually divided. This one is being used for WE department, VLAN ports 1 through 8, and VLAN ports 9 through 16 here, 16 or 15. Anyhow, this one is the maximum number, thus until 16, that can be used for this computer science department. And this one is operating as multiple virtual switches, like this. Even though that is a single one switch, that can be divided into two switches like that, but that is virtually. Thus, this one is called virtual switch, and this LAN is called virtual LAN. These ports, if we are dividing depending upon that port number, that is port-based VLAN. Also, we can divide based on the MAC address, then that is MAC address-based VLAN. But let's focus on this port-based VLAN. Traffic isolation is possible. Frames from port 1 through 8 here can only reach port 1 through 8. Those are in the same LAN. Can also define VLAN based on MAC addresses of endpoints rather than switch port, then that is called MAC address-based VLAN. Here, this one is example for the port-based VLAN. Dynamic membership. Ports can be dynamically assigned among VLANs. Thus, even though this one is included in this WE department group, this one is moving to computer science, then this port can be assigned to this computer science group, to this computer science virtual LAN dynamically. Porting between virtual LANs, then we need some mechanism to forward the traffic here to the computer science, the frame from here to electrical engineering department. That will be done by a routing. Just as you'd separate switches, in practice, vendors sell combined switches plus routers. And that router, this one can be used separately, or vendors are including them together. Thus, virtual LAN capable, this switch may have this routing capability here, and those different LAN can be interconnected through this bridge. As an analogous example, we can think this router bridge that is interconnecting that isolated island. This router is bridging that. Virtual LANs spanning multiple switches. Also, this one can be spanned with multiple switches like this. This switch and this switch can be interconnected physically. Here, then we need this port to interconnect. This is trunk port. This one is carrying frames between virtual LANs defined over multiple physical switches, and frames ported within virtual LAN between switches can't be ordinary or plain. That is special 8.1 frames. Think about Ethernet frame that is not ordinary or plain, that is vanilla. That means that is plain or ordinary. This one must carry VLAN ID information. Thus, that's different. That should be different. Thus, this 8.1q protocol that is being used for VLAN trunking. This protocol adds remove additional header fields for frame ported between trunk ports. Okay, this one is the example frame format for this 8.1q. Always think about the prefix IEEE here, because IEEE, International Electrical and Electronics Engineer Association, and that is making some standards, and this one is one of them. This one is preamble. This one is 8.1 or 8. Especially 3 Ethernet frame format, as we learned. Here 4 bytes are added for this 8.1q frame format for trunking. 2 byte tag protocol identifier and another 2 byte for tag control information, VLAN ID, and so on. Those are inserted here between this source address and the type this field. Okay, let's move to the next subchapter. This one is about MPLS, and this one is for link virtualization. And what's that? Let's go to the next slide. This MPLS, that stands for multi-protocol label switching. Initial goal was like this, but that may be used for other purpose for traffic engineering. Okay, even though the initial goal was like this, high-speed IP forwarding using pixel length label instead of IP address. And this traffic engineering, for that purpose, this MPLS may be used. And the initial goal, let's look at this one first. Fast lookup using pixel length identifier, that is label, rather than shortest prefix matching. That is our traditional IP destination IP-based routing. This is the IP address, destination IP address, about that subnet network, destination address. And this one was borrowing ideas from virtual circuit. That is pretty old technology introduced at the beginning of packet switching. And this virtual circuit, with the virtual circuit number, that may be used to configure some kind of virtual circuit network. And but IP datagram still keeps IP address. This one is keeping IP address. Newly, this MPLS header that is being inserted here between this layer 2 frame header and the layer 3 header here, MPLS header, that is. Think about special label. This one is based on that. To switch, this one will be used for that switching. Thus that is called label switching. This one is experiment, stackable, and the end of that, and that is beyond of this lecture scope. Thus you don't need to worry about that. This is detail value. Anyhow, let's focus on that. Label. Think about that. MPLS capable routers. Also, if we want to use this MPLS, then that router should be MPLS capable. Label switched router. Also, we can say this one is forwarding packets to outgoing interface based only on label value, and this one is not using IP address. Thus, this one is not inspecting IP address. Thus, in terms of performance, it will be better in terms of speed because it is not checking that IP address. MPLS forwarding table, that is different from IP forwarding table, and we'll look at that basic and very simple example in next slide. This one is providing some flexibility. MPLS forwarding decisions can differ from those of IP, and this one is using destination and source addresses to route flows to same destination in different way. That is related to this traffic engineering. Thus, traffic engineering is possible using this MPLS capable router, and reroute flows quickly if link fails. Also, that is possible. Those are advantage and the flexibility of these MPLS capable routers. Pre-computed backup passes. For example, VoIP. We can use this pass, backup pass, using this MPLS also. This one is very simple example using MPLS. And here, let's look at the router. This router is simply IP router. IP routing, in that case, path to destination determined by destination address alone. From here to this A, that is the destination address, then even though the sources are different, they should go to the same path, same route, because routing algorithm is finding that same link. No difference. But if we want to use different route depending upon the source of that datagram, then it is not possible using this IP-only capable router. Okay, let's look at this figure. Here we can see this router. This one is IP-only router, and this shaded one, this one is MPLS capable router, and also this one is IP capable. Those both are possible using this router. And here, this entry router R4, this one is MPLS capable router, can use different MPLS routes to a based on source address. Depending upon that source, if that is starting from this router 6, then that datagram will be sent through this route. If that datagram is starting from this router 5, then it will go through this route. Those different routes that is possible for traffic engineering, and that may be useful for that traffic engineering. Here, IP routing, path to destination determined by destination address alone, but this is traditional IP routing. But the new routing based on this MPLS capable router, path to destination can be based on source and destination address, as I explained, depending upon source. That route may be different. Also, path to reroute, pre-compute backup routes in case of link failure, that is possible also using this MPLS capable router. Okay, this one is just for reference. The information about this MPLS signaling is beyond our scope of our textbook, and this one is explained in the textbook, page number 522, just briefly. But this one is just for reference. Modify OSPF intermediate system to intermediate system link state flooding protocols to carry information used by MPLS routing. For this routing that may be used, for example, link bandwidth and amount of reserved link bandwidth, to consider that, and that will be used. Entry MPLS router uses this RSVP. That is the extension to RSVP for that the label switched path tunnel, and this RSVP is the resource reservation protocol, just for reference. And this one is the extension for that. Signaling protocol to set up MPLS porting at downstream nodes. And here, you don't need to worry about that. The details of this. This is modified link state flooding, and that is related to this MPLS signaling, but that is beyond the scope of our textbook. That is just for reference. This one is explaining about the basic concept about this MPLS porting. Initially, let's start from this one. A is the destination. If this router, this one is MPLS capable router, this one is advertising that the label, that if that label is being used, then that will be delivered to a destination. The label is 6, that will be advertised to this, Then this router, this one is router, which one is capable, MPLS capable router. And here, if this label will be used, then that will be destined to a destination, and that is the output interface. Also here, the output label is 6 is being used, then that will be delivered to here through this output interface 0. Destination is A. And this label from here to here, that may use different label, and this one can advertise to this. If label 8 is being used, then that is being arrived here, then that will be guaranteed to deliver to A. And this one will change that output label. And 8 here, if that is using output label 8, then that will be destined to destination A, and interface 1 will be used. In this case, number 6, then label 10 will be used here, and that will be advertised to this one, then 10, then that will be finally destined to A through this interface port 0. And this is another one, T. In that case, that is, you don't need to worry about that. That will be advertised to this one, and that will be destined finally to this T address, T network. This one is the example. And here we are using these labels, and that should be advertised. And from this one, through that MPLS capable routers, they should use that advertised labels. And they are not inspecting the IP address, as we learned, and simply they are checking that label and they are porting using that table. Okay, this is the good point to wrap up here.